Let's deploy and test the Pulsar Source Connector for Debezium Postgres. First, we're going to prepare our AWS RDS Postgres database by obtaining the hostname and default port, as well as configure the replicator for Debezium. Second, we're going to prepare the StreamNative Cloud Cluster by creating the service account binding, and supply the correct permissions to our tenant and namespace. Then finally, we're going to deploy the Debezium Postgres Source Connector using pulsarctl and test it with the Pulsar Java Client. You'll need to check the documentation, but currently the version of Debezium Postgres Connector that's going to deploy into StreamNative Cloud is going to be 29217, which uses Debezium 1.7. Here I have the documentation for Debezium. I've included that link below, and it uses Debezium 1.7. 1.7 currently supports database versions 9.6 through 13 for Postgres. I'm going to go ahead and do my testing in AWS with PostgreSQL 11. Here we have additional Debezium Postgres documentation. I've also included the link below for you for this section of the documentation on the specific requirements that are needed for PostgreSQL on Amazon RDS. You can see that we need to set the RDS logical replication to 1 and verify the WAL level. We'll be using the plugin name WAL2JSON, and then to initiate the logical replication from the AWS account, the account has to have RDS replication role. I'm going to go ahead and hop on over to AWS, and I'll show you where I've set up each of these items and confirmed them. So here I am in AWS for Amazon RDS, and I have the Postgres 11 database here. The endpoint and port number are shown here. You're going to need those a little bit later for the pulsarctl command. The first thing we need to do is set the instance parameter RDS logical replication to 1. This is done in the parameter groups, where I created a new custom parameter group based off of Postgres 11. I went ahead and found that parameter, rds.logicalReplication, and I have already set it to 1. To then set your database to use this new custom parameters group, going back to my databases, you can always go to Modify and change the parameters group here. It's one of the options in here. Once you change it, I typically have to hit Continue and say Apply Immediately, and then you may have to also restart your Postgres database. But the second set of directions says that we should verify the WAL level that it's set to logical. To do that, you can use your tool of choice to connect to your Postgres database to run some SQL queries. I'm using Debezium, and I've already connected to my database using the connection URL, as well as the default username with the custom password that was supplied. I'm using the master account. So in Postgres, I'll go ahead and right-click and say SQL Editor, open SQL Console, and all I have to do is say show WAL level. And if it says logical, we know that we're set to go on that step. The third step was to be sure to use the plugin name WAL2JSON. We'll use that a little bit later in our pulsarctl command. And then the last item is to initiate the logical replication from an AWS account that has RDS replication. To do that, all you have to do is here in for your SQL query is say grant RDS replication to, and I'm going to just be using my Postgres account. That's the one that we're also going to use to connect to from our connector into Postgres. Go ahead and execute that. And here we can see that it says it's granted that permission. And of course, to get both this application here, Debezium, to be able to execute our SQL queries, as well as to get to the connector to work, the RDS Postgres database is going to have to allow incoming traffic from the internet. Next, let's get started on preparing our StreamNative Cloud Cluster. This will include creating a service account binding, and supplying the correct permissions to our tenant and namespace. Here I've already created a service account called Sources Syncs Service Account. And over here you can see it's set to false for admin, so this is not a super user, which would of course be a best practice. Next, you need to create a service account binding. We're not going to go through the details of that, but it is a critical step. That's done using another application called SNCtl. Below, I've included a link to another video that gives step-by-step directions on how to use SNCtl to create that service account binding. Then finally, we need to supply the correct permissions to our tenant and namespace. I've already created a tenant and namespace called pgTenant and a namespace called pgNamespace. And under policy, I'm going to add a role, and that will be for our sources and sinks service account. I'm going to give it permissions produce and sources. The ability to add packages, sinks, and sources was recently added to the UI. So if you don't see those three here, you're going to have to use another application called pulsarctl to add the required permissions. If that is the case for you, I do have a link below to another video that shows exactly how to use pulsarctl to add these special permissions. I often add consume as well in case you want to use the same service account in the Java client when testing out the Debezium Postgres Connector. Next, we need to connect to our cluster using pulsarctl using the service account for which we want to then deploy the Debezium Postgres Connector. That, of course, is our sources and sinks service account, which has both the service account binding and then produce, consume, and sources permissions on our tenant and namespace. To get that code, we go to Pulsar Clients, CLI Tools, pulsarctl, click Next. You can download the CLI tools here, but I actually prefer to install it using Brew on my Mac. And I've included a link to directions on how to download and install pulsarctl in the link below. Click Next. Here I'll select that service account, sources sinks service account, the authentication type. So here I'm going to download my OAuth 2 key. And then under client configuration, I'm going to head and copy all of this code here, where the admin service URL, issuer endpoint, and audience are pre-populated. And all you need to do is include a file path to the key file location for the key that you just downloaded. I tend to put that into a folder on my desktop and then move into the desktop in terminal to execute this code, which we'll do now. So here I've pasted in the code after making sure terminal I've moved into the desktop. And all I've edited in the code before I pasted it in was I put the ./myfiles and then the file, the JSON file that I had downloaded. I moved that file into a folder called My Files on my desktop. Being sure to include the pulsarctl OAuth 2 activate. You should see that you're logged in as that service account now. So any commands that you're going to execute here will be as though you're that service account. So when we get ready to deploy the Pulsar connector here with pulsarctl, it's going to deploy it using that service account, which needs the service account binding in the background to work correctly. So let's take a look at the pulsarctl command that we're going to use to deploy the Debezium Postgres Source Connector. Anything before the source config flag is going to be pretty general and typically very similar for any of the connectors, sink or source connectors. And then anything that's inside of the source config flag is going to be very specific to whichever connector you're deploying. Starting at the top, we of course use pulsarctl sources, since this is one of the source connectors. We say create and then archive built-in Debezium Postgres, meaning it's going to pull the nar file directly inside of StreamNative Hosted. I want to deploy it to the tenant pgTenant and the namespace pgNamespace, which I've already created and applied the correct permissions to deploy a source for the particular service account that we're logged into pulsarctl with. We're going to name the connector PG source, so that'll show up as once it's deployed and you want to view the stats on the connector, it's going to be called PG source. And then a destination topic name, we have to again put the tenant and namespace and then the name of the topic. This isn't necessarily this is not the name of the topic that it's going to deploy the actual Debezium Postgres data to. You'll see that in a little bit once we deploy it and start reading from our users table. Inside a source config, this is where the Debezium Postgres Connector specific configuration is done. Database hostname, of course, we already showed you where you get that out of RDS and the database port number. I'm using the default database user of Postgres, and I've included its password here. And then when I looked in dbeaver and I logged into my Postgres database, I saw that the database name was Postgres. And I'm assuming that's what the AWS calls all of the Postgres databases that are deployed. I'm not sure, but that is what I saw when I went into dbeaver, so that's what I place here. I'm going to include a table whitelist, and I'm going to say include all data from the public schema and the user's table. You can include a comma-separated list inside of those double quotes if you want to read data from multiple tables. The database server name, I'm going to call it my DB instance because that's what it's called in AWS, and that's going to be included in the topic name that gets created inside of Pulsar. So your topic names are going to be named based off of that database server name, dot the schema, which here is public, dot table, which is users. And then the plugin name, because we're using Debezium 1.7, you use wall2 JSON. And here I've pasted that exact code into terminal. And again, I'm logged into pulsarctl as the user that has the service account binding and the permissions on my tenant and namespace. And it should say created PG source successfully. So here I am in the StreamNative UI. I've already selected my tenant and namespace, gone to connectors, but I still need to click over here on created sources. You'll go ahead and see here that PG source is now deployed and ready. If I go to topics, I'll see that there's the PG output topic and the offset topic, but no particular topic related to my users table. So let me go ahead and create my first write into my PG users table since the connector has been deployed. Let's go ahead and test out the connector. We're going to do this by making some changes to the database and then seeing how those changes get propagated over into StreamNative Cloud. So I'm going to go ahead and type in the first name, or I'm going to add a new entry into my users table. So I'm going to add a row, say Justin, Nest, and then gender we'll say male. And I'm going to go ahead and save those changes to the database. And then I just noticed that I didn't capitalize the J, so let me go ahead and make an edit to a row. And I'll save again and persist that to the database. Going over to the UI, I can now see in my source connector that there were 2 messages read from the source and 2 messages written to Pulsar. If I go ahead and go to topics, you'll see that there's now a topic that is my db instant.public.users. And then if I click on that, I'm going to manually add a subscription and see if I get a backlog, if those 2 messages make it into this backlog. And sure enough, it said those 2 made it into my backlog. I'm going to now go over to the Java client and consume these 2 messages and see what they look like. So if you aren't familiar with the Java client, you can go ahead and go to the UI, to the Pulsar Clients tab on the left side of the UI, and there's some example Java client code there. But here I have pasted in some code, making sure I have edited the credentials URL. This is actually a super admin account, but we could technically use that service account because we did add consume permissions onto it. This is also my topic PG tenant, PG namespace, and my DB instance.public.users. And then I've put in the subscription that I manually created in the UI. I didn't have to make it in the UI. It would automatically create the subscription, but I manually created it there just so I could check and make sure the 2 messages made it into that backlog. I'm then going to just print out the messages to the console. So let me go ahead and right click here and say run Debezium Postgres. That's the name of my class that I'd created. And we'll see the 2 messages get printed out to screen here. They are in JSON format. Here it's before field is null because this was a new row. And then the after field has my first name, last name, and the gender. And then there's also a bunch of source information. The second message coming through has the before, the first name, last name, and gender. And then after it has the changed first name, last name, and gender. Sometimes you may see that this before field, while it may not say null, it may have all the field names, but they may not be filled in. You may need to make a change. I'm going to go ahead and put that up on the screen. I've read a little bit about it on the internet. You can see that it may have something to do with whether or not you have a primary key to your table or not, but there is a command that you can run to make sure that it saves both the before and after condition in case you need that type of data persisted into Pulsar so that you can then use the before versus after in your applications.